So what we do, we will try to start understanding Kubernetes. Now, that is a very, very important tool or a software, a software tool in the DevOps lifecycle. Like one of the important tools where the CI/CD pipeline, Azure DevOps. Similarly, this is one of the important tools in the deployment aspect of this thing. So I will go by this, or shall I make it a full screen? This is better, right?
Yeah.
Okay. So we have a DevOps tool chain, and you are now after so many sessions, though it is internet, I mean the in internship sessions, so of 2 hours, but you are very well aware of this particular DevOps cycle, isn't it? And these are the various phases of the DevOps cycle, or you can say the SDLC life cycle. SDLC is the software development life cycle. So where you start planning to deliver a software, you will start planning and designing. Then you go to the coding, then you build, then you give it to testing, then test. After the test is fine, you will release it. That is, this is delivery part. You have seen that publish, copy, publish, and release. And therefore, then deploy it with a proper packaging. Okay. And deploy it. And here comes where you are deploying it. You are deploying it over an orchestration tool called Kubernetes, because if you have Dockerized, or if you have put your application into as an image inside a container, then there can be lots of containers, hundreds and hundreds of containers or microservices packaged in form of pods. Pods are nothing but containers. We will come to that, all those terms, very important terms. Now, to manage them is not a very simple task, because you have hundreds of pods. Pods are single units of that microservices running inside the container. Okay. So you have to maintain the health. You have to know which container has gone down, or which one is working fine, which one is available, which one can take the load. All these things are not very easy if you think of it. This is the operations part. So you have put it, you have deployed all your application through microservices over into your, this can be a pre-production box, or this can be a production box. Okay. The environment has been created through Terraform. That is, you have provisioned the environment, you have provisioned the server, the network, the storage, the memory, and all sorts of things that you have, the S3 buckets, everything that you have done is through Terraform. Then you have configured the environment through Ansible. That means you have installed the relevant softwares for the compilation and all the stuff that is needed, or to setting up the environment, tuning the environment, patching your security patches, and all the stuff. That all will be done through Ansible. We have done all these things earlier. Now, at the same time, those hundreds and hundreds of microservices as an application will be deployed over Kubernetes orchestration. That is, this part is what we are going to learn. And once you have deployed it correctly, then so these are running, but since it is in production, you will have to monitor it. If there is, you will monitor it through Nagios or Splunk or Datadog, whatever it is. Okay. And then, or maybe through Prometheus. And then that will give a feedback back to the, if there is any issues, it will go back to the coding or the development team, and again the cycle will be repeated, and again the fresh set of code will be deployed, and all those stuff. So the cycle goes on and on and on. So it's a very nice diagram where each and every phase, what are the tools, what are the DevOps tools that you can use, is depicted. Any question? So Kubernetes fits in the DevOps toolchain in the operate phase when you finally deploy. Okay. So now what is the DevOps journey? So when you are with us, we will guide you whether you have to take this DevOps course. That is, you have to learn DevOps properly, whether it is fundamental or advanced. Now we consider Kubernetes part of advanced DevOps. So in our paid training course of 2 months, of you can say 8 weeks, we have merged Kubernetes course with the DevOps. These are fundamentals, but it is not only fundamentals. This we teach in details and with lots of hands-on practicals and labs. So you become a pro. So what we do is prepare you with, because many interviewers will be not only interested with your understanding of DevOps, understanding of the various DevOps tools, how good you are in that. At the same time, they will surely be asking questions on Kubernetes, because Kubernetes is now a basic requirement of, if you are aiming to be a DevOps guy or DevOps engineer, sorry, your knowledge of sorry, your knowledge of Kubernetes is a must. So even you are going into entry level of DevOps, they will still ask whether you are comfortable with Kubernetes. And if you are, then you have created yourself or differentiated yourself from the crowd. There will be many people going in for the DevOps interviews, but since they will lack the knowledge of Kubernetes, you cut an edge over them. You will impress. So our suggestion is that while you learn DevOps, you must learn Kubernetes. That's why we have merged Kubernetes, though Kubernetes comes in the advanced DevOps. And there is SRE, Site Reliability Engineering. This is a set of tools, very important tools that is you learn, specifically those who are aiming to be in the operations. Operations form the backbone of any big organization. And if you know the SRE, ELK products, okay, there are 3 ELK products. I will not go into the details, but that is mostly for the monitoring and the health checks. And basically, you are converting those big log files, which are unstructured data, into the structured query so that you can query through SQLs. And then you can display with the Kibana dashboard. You can display a lot of graphics and what is happening, where there is some leak, where there is a lot of memory that is getting used, where has the memory leak happened. All these things you can easily, by interpreting on the logs, and the logs are, you can take it from me, the logs can be huge. But learning these tools, SRE, will make your life very simple, and you will be the most go after guy in the organization, because you know DevOps, you know SRE along with Kubernetes. So you are the most looked after or most favored or most like blue-eyed guy in the organization. You are a go-to guy. Now, many people ask whether learning SRE is a must. I will say no. It is good. It is good to have a knowledge on SRE, but you can skip this part. SRE. You can learn DevOps along with Kubernetes and then straight away jump into DevSecOps, which is cybersecurity. And nowadays, learning cybersecurity is not complete if you do not learn DevSecOps, because most of the 90% of the companies have implemented DevOps in their organization. So as a DevOps engineer, you are required to work with them. But at the same time, you can also learn cybersecurity with DevSecOps, because that is giving you a big edge. The assets that you have created using DevOps should be secured. That's why you learn DevSecOps, which is a part of cybersecurity. So you have to you have learned pipelines like Azure DevOps. Now, how you will secure your pipeline? The pipeline is automated, but how will you ensure that it is not hacked? It is not secured. It is secured. It is by learning DevSecOps. So I will suggest that you learn Kubernetes along with DevOps and jump into learning cybersecurity of DevSecOps. Any question? So that is the most, that is the best roadmap. If somebody is going like this, then there is no competition. Nobody can compete with this guy who has learned DevOps in the proper way, learned Kubernetes in the proper way, learned SRE in the proper way, and then learned, devoted his time. So this is the growth roadmap. Once you learn all these three, you are the most sought after. Your salary will be, I mean, it's quite bigger than others in the market, other like those who are just knowing DevOps, or those who are just knowing SRE. A person who is learning all the three of them is mostly highly paid. Like these are your top 5 skills in demand. You have to know what are the things that you should learn, because if you learn everything, there is no value. You have to learn. When you give an exam, you must not prepare. It is good if you prepare for everything. If you learn everything, that is good. But for exam preparation, you need specific chapters to be learned most properly. Here also in the job market, you need to know which skills you need to grow. Like it has been reviewed by, as per LinkedIn, the most sought after job portal. Okay. So the LinkedIn suggests that the most demanding few skills, which is Linux. First of all, you need to know Linux, because you are a developer, you are a DevOps guy, you are a SRE guy, you are a security guy, cyber security guy. You cannot say that I would not learn Linux. You have to learn Linux. So this is the skill that you have to grow. If you don't have, no worries. You start growing with us. Okay. Then Docker. The concepts of Docker, you have to be very proficient in Docker. Then shell scripting. The shell is a part of the Linux. Okay, but you need to know a particular shell scripting. Okay. So because as I told you, in the pipeline script, what you've seen is all shell scripting. There is no Python, there is no Groovy, Go, anything. That is important. So you learn shell scripting. Next comes Kubernetes. Anything and everything is this. And then one cloud, whether it is AWS or Azure or Google, GCP, Google Cloud Platform, or IBM Cloud or Oracle Cloud, any one of the cloud. But AWS being the most popular, you can learn. AWS is a bit easier to learn than in compared to Azure. That's why most of the people learn AWS. But see, cloud technology remains the same. And if you go by the category of the job role, So the highest demand is for a development or an engineering guy, 23%. Next comes DevOps or SRE guy, 21%. Then a project manager or any Scrum manager or whatever. So that is 18%. And then comes the operations or infrastructure guy, 9%. So you can see DevOps is quite high on the rank. Any questions so far? Anyone having any questions, please? We have just not started even Kubernetes, so let us go into that. So Kubernetes has been designed by Google. So G should be capital anyway. That's a wrong thing. So it has been designed by Google and it is currently maintained by the Cloud Native Computing Foundation. So you can see the combination of these two. These are the giants. Google is the giant, you know. So if something is coming from the house of Google and therefore you can easily stay in the market for future for very long. You have to know Kubernetes. Then Google will come up with certain other. So already the version number 31 is in the market. Can you believe? Already 31 versions are there. So Google is very smart. They keep on upgrading. But if you do not know Kubernetes, what will you do with the upgrades? You have to first learn Kubernetes properly. So Google will take you to the future, but learn the basic architecture, basic things of Kubernetes. And then this one has been endorsed by CNF, Cloud Native Computing Foundation. So which is a like you have WWW consortium for anything governing internet transactions or internet processing. So it is WWW. Similarly, anything governing the cloud, anything that you deploy on the cloud, anything that you are the architecture that will work the best on the cloud, all this, the network that works on the cloud, the edge computing, everything will now be standardized through cloud native computing. So if Kubernetes has been one of the products that is maintained by CNF, that you can understand the importance of this product. That is why it is so popular with the industry. And also at the same time, it is open source container orchestration system. Open source has the big advantage of that you can learn it without paying a single penny or a shilling or a cent. So this is one field. DevOps is one field. Why people come to DevOps first? Because it is developer. If you want to become a developer, the market or the field, the development field is almost saturated. There are big developers. How will you compete with them? Many people who join our course come from various different backgrounds. Some is coming from accountancy. Some is coming from, even we have Uber driver. He wants to change his profession. He wants to come to IT. How will he do that? And you know, the person who came from Uber is now doing an IT job after he has been trained through us. So it is what I'm saying. The basic thing is, uh, this is one opening to the world of IT. It is the one and only one is the DevOps. You cannot directly jump into cybersecurity from some other domain. You have to come through because something you have to learn and how, and without spending a lot of money on the softwares, on the tools, because all of the DevOps tools are all open source. That is the biggest advantage. You don't have to spend a single cent over purchasing the license. Whereas when you join your corporation, your company, you will be working on the enterprise version of whatever open source you have used. So whenever you have learned Kubernetes, it is on an open source community version. But when you are working in your this thing in your company, then they are going to use enterprise version, which is which has a few more functions or few more features available than your open source version, community version. Okay, but otherwise everything remains the same. Only that if you want to deploy something over commercially open source, you cannot do it through open source. You have to go for an enterprise because it will not be published or it cannot be launched as in the market without a licensed orchestration tool like Kubernetes. So naturally, you learn it through an open source, but when you use it, you will be using it in a company where they are learning, where they are doing the license version. What is it doing? It is automating application deployment, scaling, and management of what? Of hundreds and hundreds of containers that has been deployed. It can scale up, scale down automatically. It will help in your application deployment very seamlessly. You have heard about blue-green deployment, canary deployment. Okay. So all these deployments are possible because you are going to use Kubernetes platform. I'm not going to do much about this. What is the power of Kubernetes? Uh, you can, when you learn it in details, what is the power behind. So rollout management, as I was telling you, the rollout, you will do it in a phased manner, either through blue-green deployment and this. So this technology will help you to do automatic deployment without any downtime. And that is why it is so popular with the industry, because the clients whom the industry serves does not prefer any downtime. Because you see, can you think of Amazon going down for 1 minute? What will happen if, say, Microsoft Azure Cloud goes down for 1 minute? Leave the question of 1 hour. It can be millions and millions of dollars loss to the business of Microsoft. So no client will like, and many clients have based their applications based on the cloud of AWS, Amazon, or Azure, or Google. So their application, when hosted over the cloud, can AWS afford to have a downtime? But AWS also have to keep on upgrading, patching. So many things are going to happen in the background, but it should not make your clients know about that. So that is the biggest thing. That is, your deployment, whatever you are doing on the back end, should not impact the client which is running in the front end. It has to be so seamless. It has to be so well planned. And there are technologies to support you. That is the blue-green deployment, canary deployment, and other types of deployments that you do. And it is possible because of Kubernetes. You can have a resource bin packing. That is you can declare the minimum and the most configured resources. That means you can have the minimum and the maximum of resources configured for your containers. So while you are designing your deploying your containers, you can at the same time through Kubernetes, you can declare through the manifest files of Kubernetes, you can declare what is the minimum amount of resource this container is going to take, and what is the maximum of the resource. And you can specify a limit. Okay. So what happens is it is not going to potentially hog all the resources without even using it. No need. Earlier days it used to. You are not using it. You are using only 20%, but you have occupied 100% of the resources. That is a bad design. So use you occupy what you use. You do not in advance book your memory, because those are costly and you have to get them. Those are costly resources which you need to leave it alone for the other applications or other uh, say configurations to pick up. But at the same time, you will see that when you can do a configuration over the Kubernetes in such a manner, it will save a lot of price, because you are using, so use pay as you go sort of a architecture or tariff. So you must pay what are you using. You must not pay for things you are not using. So if that is so, then you are saving a lot of money for your company. And that is where you use Kubernetes. And Kubernetes can do a lot of auto scaling. Lot of auto scaling. So you have initially said that I want this much of CPU, I want this percentage of memory for my containers. Okay. But when the demand of your containers increase, when there are lots of traffic using your containers, it increases. Then there is auto scaling. Who is providing that auto scaling automatically? Kubernetes. And when your crowd increases, say today you have 100 microservices in your environment. Tomorrow, or maybe down the line, 1 year down the line, you have 1,000 of microservices. What is then? What is happening? The crowd has increased, a lot of traffic. Okay. So out of the thousands and thousands of microservices, you want a particular service to be hit without loss of time. So to discover your particular pod or your particular container with a particular application is the most daunting task. The most like most of the engineers will be scratching their heads over how to take the minimum route to reach to a particular endpoint. That is the most pertinent question that the is faced by each and every one working on the system, a very highly complex system, because microservices itself, they are very complicated architecture. And on top of that, you are deploying hundreds and thousands of this over the Kubernetes. So who is managing that? This is a SaaS platform, software as a service. So Kubernetes is a configuration, is a platform, but it is also at the same time a SaaS based application. So it will manage everything by its own. You do not need to write a single line of code to let Kubernetes do what it needs to do. No, dynamically on the runtime, in the runtime, it will manage your, it will do the auto scaling. It will, it will, it will discover your out of the crowd. It will take the easiest and the shortest route to reach your, what is that? Your container. So discovery mechanism and auto scaling are all inbuilt within Kubernetes. And it's a big, uh, that was a nightmare. That nightmare is now gone. For the development team, for the operations team, for the testing team, everyone had a big headache of how to manage those hundreds and hundreds of containers over the web. So Kubernetes can also use heterogeneous clusters. So cluster is the most important part. You are managing a lot of nodes through a single node or a multiple nodes, which is called the master node. So a master, uh, it's an architecture, cluster architecture with the master and the slave sort of an architecture. The slaves are the nodes where your applications run, and the master is the controller plane that will control all the nodes, all the pods, all the containers, and maintain the health. And so the cloud or the cluster can be heterogeneous. It can be a combination of on-premise and your data center, or it can be a combination of your data center with the cloud, or it can be a combination of data center, on-premise, and the cloud. So lots of combination can happen where your servers and the nodes are scattered. So it will support heterogeneous clusters. Persistent storage, because the containers cannot, containers are, it is one term is there. What is that term? Can anybody tell me? Containers, while in Docker, we have learned that. Docker containers are what? You have learned are temporary, ephemeral. What is ephemeral? It's temporary. That means what is temporary with respect to the data. So you cannot store your data in the container. It is like a RAM, random access memory. It is not a RAM. I'm just giving an example. Like RAM, as long as your system is on, whatever you store in your memory called random access memory, it is on. Once you shut it off, all the data is gone. Or whatever you have stored in the memory inside the RAM is gone. So it is called ephemeral or temporary. Similarly, the containers, you can temporarily store data over the containers, inside the containers, but in the volumes called containers. Those in Docker volumes, you can store in Docker volumes permanently. And but since we are not using Docker architecture, we are going to use Kubernetes. Therefore, Kubernetes gives a persistent storage called PV, persistent volume, like here Docker volumes to store data permanently or as long as you need. So here it is called persistent volume, and the mechanism to claim the data or to use the data is PVC, persistent volume claim. So you claim the data you have stored, and this is a shareable unit. So this PV is shared between the pods. So it is shared between the pods. So nobody is the owner of this PV. Everybody but can share the data from this common pool, shared pool. So nice arrangement. But then if you want to claim it, you have to use another persistent storage object called PVC. Anyway, that is beyond our scope to learn. But as I'm telling you, so it can store your data as and when, and the data can be huge, big. All can be managed through Kubernetes. Kubernetes is a fantastic thing. It is not only discovering your services or doing this, managing your pods, it can give a lot of other features. Storage is one of them. Cluster federation is a very, very high advanced concept. But all these are convenience options available with Kubernetes. Any question? Now, why the industry has adapted Kubernetes? There are 7 big reasons. Simple app. So the Kubernetes, once you know it properly, you will know that deploying it on Kubernetes cluster, deploying your applications over Kubernetes cluster is a simple thing. That is one big advantage. It can handle hundreds and thousands of microservices with ease. And the world is moving towards microservice. What was the earlier technology called? If you are not using microservices, what is that called? What type of application you would be using instead of using microservice application earlier?
Monolithic.
Anyone? Monolithic. Fantastic. Absolutely. Absolutely. Correct. Monolithic. Mono means one, lithic means layer, one layer, single layer. So they are very tightly coupled. Tightly coupled. All the functions, all the modules within the application is one single layer. So they are very tightly coupled. So if one function goes down, the entire application will go down. Whereas it is loosely coupled because these are microservices. They are not dependent or tightly coupled with the other containers. Okay, so these containers, they can work as a single application. Say this is a login application. This is a authentication application. Oh, sorry. And this is another pod which is giving you payment gateway application. So no one is linked to the other, but if login needs to talk for the authentication, so a person logging in, whether the person is authenticated, maybe the login is valid, but whether there is another second level of authentication authorization, so this application will be called. So there can be a link between the two microservices, but otherwise they can work as a single unit. When needed, this can call this. It will not call payment gateway. Login will never call payment gateway because there is no dependency. Here, it can call authentication to authenticate the user. The user wants to log in. Okay. Again, maybe the shopping cart, the cart is another microservice. Now, shopping cart can, so whenever you are ordering something, you will use the payment gateway. So there can be a call between these two. So there can be some links, but otherwise they are loosely coupled. That is and this architecture is quite complicated. It is not that simple. But what happens is this complicacy can be taken over by Kubernetes. Kubernetes will take care. You do not have to scratch your head over how to manage things. No, you just as a coder, as an application developer, you just concentrate on your functions. When you deploy it, everything will now be taken care by how the health is managed. If this pod goes down, another pod will come up with the same functionality. So the availability is a very important concept. Atomicity, dependability or reliability, dependability, okay, trustworthiness. All these things are very, very important features of orchestration, of an orchestration tool. And all this will be provided by Kubernetes. Scalability. So this should not happen that the user is going to log in and the login function becomes very slow because there are thousands and tens of thousands of users using the logging function. So it should go gradually. This performance goes down, degrades. No, it does not. A aircraft, sadly, there was an accident in India. A aircraft has a capacity of 240 passengers. Okay. Now, will it will it be too heavy when 240 passengers are onboarded, or it will be too light when only 40 passengers are on board? Does it Will the performance vary when it is 240? Uh, it will become a bit slow in the year, and when it is 40, it will be very fast. No, it does not work on that principle. If it's so, then it is a faulty mechanism. Similarly, in the microservices, whether the number of hits or number of the traffic grows again and again, will the performance of this particular function degrade? No, then it's a bad design. So if now definitely it will need a lot of resources as more and more and more traffic goes into it will. So there is an automatic scalability. The number of CPU, the number of the amount of memory, percentage of because as I told you, with each and every container was initially assigned with certain percentage of CPU, certain percentage of memory to use in the idle condition. But when more and more traffic goes in, the resources, there can be a resource crunch. And then automatically Kubernetes pitches in, it can, because it monitors each and every health of each and every pod. And thereafter, it will scale automatically on the fly. So the availability is always there. Atomicity like you have started a bank transaction, your account is debited because you are giving some money to another account which was supposed to be credited, right? That is a banking transaction over the internet. Now, what happened is if this transaction is not atomic, what will happen? Your account will be debited, but this account was not credited. Will you say that this process is correct? It cannot. Then there is a big issue. You will raise a dispute that your account was debited, but the amount which was supposed to be credited to that account was not credited. Somebody has already siphoned the money. No, then that is a bad system. It is not called atomic. It has to be atomic. If it has started, it should reach the goal. Similarly, any microservice function should be atomic. It should be dependable, trustworthy. That means if it has started one transaction, it should complete. If not, if for some technical reason, if the account was not credited, so the money should be refunded back. This is dependability. This is trustworthiness of your system. That since something happened at this end, some network failure or something, it can be anything. If the transaction could not go through, the money should come back, refunded. If that is happening automatically, then you can say that this system is dependable. This is trustworthy. Lift and shift. You can lift your application from the on-premise, that is from your office to the cloud, very easily through Kubernetes. Kubernetes can help you do this shifts, lift and shift, as if you are lifting your application from your office or data center and putting it into the cloud in the public place, or leveraging the maximum utilities of processing over the cloud. Okay. And of course, this entire Kubernetes is over the CNF. That is why it is so popular. It is maintained over the network functions which are designed and hosted over cloud native network functions. It will enable your processing of machine learning. That means AI enabled computation is possible on over Kubernetes. It is therefore, since AI is also entailed to heavy computing, it enables computing heavy tasks like big data, Hadoop. It can process big data over the Kubernetes architecture, which are huge petabytes of data and requires heavy computing. Even the machine learning requires heavy computing. And of course, one of the most important aspects of using Kubernetes is because it can support the automation of CI/CD pipelines. So CI/CD tasks are easier to perform with Kubernetes. So you deploy your CI/CD pipeline over onto Kubernetes. That is what an example I have shown you in the demo in the last class, isn't it? It was so simple to deploy it over Kubernetes, and your pipeline will run automatically on Kubernetes with all the pods that it deploys, everything maintained by Kubernetes. So can you see the advantage of having Kubernetes? So that is the 7 popular reasons why industry has adopted Kubernetes. Any questions from this end, from your end? Are you finding it difficult? Hello? Are you finding it a bit of, there is any difficulty, or you are finding it interesting? We have not yet gone into the architecture. Let us go into that architecture. So we have one more hour left, and I think we can cover few more slides. And after that, on the next weekend, we will complete the entire discussion on Kubernetes. Is that fine? So let us move ahead. Now, coming to the role of Kubernetes. As I said, that this is the monolithic application where you have the front end, back end database. Front end is, all the applications which are running on the front end. It can be Angular, it can be React, it can be uh, Vue, it can be Oracle Financials. So many things they are running in the front end. Okay. There is the back end. Back end is the sort of a middleware where your business logic is processed. Business logic is the finally what will be the business logic, that is what the business wants out of the data, out of this process. So some logic will be given, some intelligence will be built into the front end queries, and then those thing will interact with the database to see, after all, the front end or the users who are using the front end actually wants to access the data through some logic to get the final result, some dashboard, some graph, some output, so that they can understand what they are looking for. The information is what they are looking for, and information is stored in the database. But how you represent that information is through some logic. Okay. But this is all built, all these functions are built within one layer monolithic application. They are very tightly coupled and not independent. If your front end and back end is working fine, but your database is down, nothing will work. Your application is down. But coming to microservice application, you see, I'm a user, I'm still using the front end. Front end is using the back end is using the database. But there is a big but. So the database is, for the security, it is having a database logic over here, but the main storage is done on the cloud, over the cloud, persistence storage, because it is much more secured. Then, so it may happen that a user can get an access to your database and your data can be hacked. But this database, the user will never get an access to this storage. There is, because it is stored over the cloud, and the cloud has lots of security measures inbuilt. So this is possible because now you see this is a microservice, this is a microservice, this is also a microservice, and there are hundreds and hundreds of other microservices waiting to be deployed into the architecture. And there is no issue. But if you want to put in one more function into this, they will not allow. Either you have to overhaul the entire thing, integrate those functions into that single layer. But here you do not need to maintain any layer. You just, this is a function. These are all small microservices. They can be integrated in the same environment, Kubernetes environment, deployed. Everything will work. Of course, the user wants to access the backend. Okay, so it has to reach the endpoint in the shortest possible route. And these routes are determined by the, can anybody tell me who will guide the user to access the containers? Just a wild guess. Just a wild guess. Somebody is helping the user to get into that container or access that container. Who is that great person? So these are microservices. In the name itself, there is one thing called service. So the microservices can be reached through the services provided in the Kubernetes cluster. We will come to that. So there is a need to maintain and monitor and govern the containers for their health and stability and availability, that there is a need for container orchestration. So now do you understand why there is a need for something which can orchestrate, which can coordinate the orchestration between the microservices? So like I given an example earlier day about the orchestra. There are hundreds of musicians playing their instruments, but there is one conductor who is conducting the entire music. So he has a sharp ear. One string goes out of music or out of that rhythm. Immediately the conductor can understand which particular instrument has gone wrong or something has happened. Similarly, Kubernetes can understand which particular pod or container has gone wrong or which particular microservices. So it will keep on a strict vigil on each and every container available in the system. So to maintain their health and stability and availability, okay, you have one great conductor of the orchestra. So that is called the container orchestration. Any questions? Now, if you have understood up to this point, it is very good. You understand the need of Kubernetes orchestration, because I have just given three containers. But can you imagine that within this cluster, you can have hundreds and thousands of such microservices scattered over, say, 30s and 40s of nodes. Nodes means servers. Can you believe? There can be 40 servers under one master controller. And within the 40 servers, there can be each node can have thousands of microservices, but all within one single microservice cluster architecture of maintained by Kubernetes. Can you believe the complexity. That is the beauty. That is what you need to work with. And the company who is employing you will surely need you to manage that show. Yeah, you will have a team of DevOps guys, but you are the one who knows Kubernetes in and out. Even if not in and out, your knowledge, uh, whatever it is, will be more than enough to get you a job. So the role of Kubernetes is trend from monolithic to microservices. That is one trend for which you need to have a microservices manager, which is the Kubernetes through a container orchestration. And you daily on a daily basis, you are going to increase the use of containers because your thing becomes so easy to deploy over the Kubernetes. So you can, today you have done one function, you deploy it. Tomorrow you have developed 5 more functions, you deploy it as a microservice over Kubernetes. That way, the number of containers keep on growing. So the features of the orchestration tools that needs to offer is high availability or no downtime. So if you are going unmanageable, you are putting so many microservices on the Kubernetes and Kubernetes is failing to manage them, then I will say your architecture is not perfect. Though you are using Kubernetes, but your configuration is not making it highly available. So there should not be, it can afford 0.1% of downtime, but not more than that. So 99.99 should be your availability time. Scalability or high performance. So I should not allow the flight to lag that push when it is taking an upward movement, when it is taking off. If there is not enough power in the engines, then what will happen? The plane can go down, can wobble through and get an accident. So the scalability or the high performance is most important part. Disaster recovery. That is, a disaster can always be there. You cannot avoid a earthquake. An earthquake can be there anytime. But you have to have enough measures to counter or prevent the fallout of an earthquake. So of a disaster can happen, but you have to be prepared well enough to recover that disaster. So there has to be a backup and restore, automatic backup and automatic restore. All these things you are not doing, Kubernetes is doing for you. Okay. Now we are coming to this Kubernetes cluster detail. Here. So what does this cluster say? Cluster, this is the entire cluster. Okay. So starting from here, ending over here. So does this blue boundary is the Kubernetes cluster. So this is the Kubernetes symbol. This is K it is. By the way, Kubernetes is K and S. And the rest, there are 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. So it is K8S. Okay. So this is a Kubernetes cluster. You have to, we learn how to create a Kubernetes cluster from the scratch in our training. in the 2 months training that we learned. That is the most important part. You have to know how to configure your cluster or create your own cluster. Okay. So there you will create one master node. To start with, one master node and at least two worker nodes, 1 and 2. These are servers. This is also a server. This is also a server. This is also a server. So this is called master and these are called slaves. Slave in not the wrong sense of the term, but just to indicate that there is, if this is called a master, then this is a slave. Because the slave will act as per the wishes of the master, as what the master instructs them to. So these are nodes where you will deploy your applications. You will never deploy, or the Kubernetes will not allow you to deploy anything on the master. You know why? Your applications, whether it is a Java application, Python application, PHP application, anything, .NET applications, all these applications in form of containers will be deployed on the worker nodes or on the slaves. Okay? Do you agree? So this is the basic, say 1 is to 2 cluster. One master which handles 2 slaves, 2 worker nodes. This is the basic architecture of a cluster. It cannot go minimum. So if you say one master and one node, it is not necessary. It is a bad configuration. At least you need to have, this is the simplest. This is the simplest and this is the basic. But you will not understand the value of having multiple nodes and your pods distributed between the nodes. So at least you can have a basic structure like this. One master node and 2 worker nodes, where your pods will be, or your replica of the pods will be distributed between the nodes. Because if one node goes down, the other node is still there. So all the pods will migrate from the tainted node or the node which is out of capacity or something has gone wrong. Those nodes or those pods will be migrated automatically by Kubernetes over onto the worker node which is running properly. And all the traffic which was accessing the pods on node 1 will now be redirected to access the pods on node 2, because there is some issue, some taint. The tainting will be done by Kubernetes automatically. Tainting means you are marking this node as something has gone wrong, faulty. This is called tainting. You have tainted. Kubernetes has marked this as tainted. So no pods will be regenerated or generated or created or maintained over here. All the pods will migrate over there, and it will. So the users don't have any. The users who were accessing this node transparently will be accessing the other node. Nobody knows what happened in between. That is the architecture. Okay. Any question? So once you have established a cluster of one master and 2 slaves, Then actually you have installed the control plane on the master node and the data plane on the worker nodes. Data means because they will hold the pods or the containers, the applications. That is why it is called the data plane. And this is called the control plane because it controls. What are the components on the master? This is one of the vital components, HCD. I will come to this afterwards. API server. This I will say heart. If you consider the cluster as a body, this is the brain. This is the lungs. This is the kidney. They are all vital parts of the body. With one malfunctioning, the others will start malfunctioning. And specifically, when your heart dies, the brain will die automatically because the heart will send oxygen to brain, the blood. So if the heart dies, the brain is bound to die. And similarly, all will fail. Lungs will generally, because the heart is not pumping into anything into the lungs, and the kidney will also not filter anything out. So everything dies gradually once the heart dies. So which one is the most important part? Which one is the most important thing that we need to consider in these components of a control plane or master node is the API server. API server is the control center of the control plane. Everything will come in the API server. Everything will go out from the API server and on the instruction of the API server. So you have to give, somebody always gives important to brain, but actually your heart is the most important part of your body. Because if your heart is healthy, your brain is also healthy. Okay. HCD. HCD is the key value store. Key value store means it is, you can say this is a database. It will store all the information that is available throughout the cluster. Nothing will go missing from HCD. Even the slightest of modification changes, something has gone wrong, everything will be captured in HCD. But through whom? Can anybody tell me? Who will feed in those data or feed in those information into the HCD? Under whose instruction HCD will get those data and store them as key value store? As I told you, everything will come in and go out from API server. So if anything information is coming out from the worker node, something has gone wrong, who will receive it first? On the controller. API server will get that information first, and immediately it will pass on that information to be stored onto the HCD database. Any question? Then you will ask me, fine, API server gets everything from outside or from inside of the cluster. That's fine. But then what will it do? So the first thing that API server does is store whatever it has got into the HCD. And then based on that information that is processed over here, it will send it to scheduler. That information that, see, Mr. Scheduler, I would like you to do something for me. Scheduler will contact the controller manager. It is like this. Will contact the controller manager, and because everything with which goes out, yeah, of course, it is through the API server, but everything which goes out or comes in is through the controller manager with the permission of API server. So the controller manager in turn will have several other controllers. That's why it is called controller manager, because there are replication controller, there are node controller, there are so many other things that is managed by this controller manager. So let's say, let me take an example. So this worker node is working with this pods. Can you see pod 1, 2, 3? Let's say this is one particular Java application with 3 replicas. What is replica? Can anybody help me?
It's copy. Replica means.
Exactly. It's a clone. That means whatever application, let's say Java application, whatever function it is having, that I have made a replica of this thing so that the same Java application with the same function is available on the 3. So I say it is a 3 replica of the same application. When we have created a manifest file of Kubernetes, we have that deployment file. Through the deployment file, which is a manifest file, we are going to create our pods. Pods are nothing but, we will see, these are containers. A layer, an abstract layer will be there on top of pods. Why? We will come to that. So I have 3 replicas of the same application. Now, this pod has gone down. This pod has gone down. How many left? 3 was reduced to 2, right? Now, this is not a desirable state. I wanted every time 3 replica of the Java application should be running at any point of time. This is not desirable. So if this is not desirable, this information, so kubelet is another component on the worker node. Kubelet is called the pod manager. Pod manager. It will manage the pod. So this is the manager who has only the task of keeping a tab on all these pods, micromanaging the microservices. If there is some issue with any pod, something going very slow or something not getting enough resources, all these things, or maybe the pod has gone down altogether, what will happen? The kubelet, now kubelet cannot do everything by its own. It has got that information. It has checked, monitored, and found that pod number 1 has gone down. What will it do? It will contact kubeproxy. Kubeproxy is the network element. You need that element because somebody has to take, this is a component of Kubernetes on the worker node side. This information needs to be taken to the API server. By whom? Kubelet cannot do that. Kubelet will send this information over to kubeproxy. And kubeproxy, so kubelet has gone to, with that information that one pod is down. So kubeproxy will take that information. It knows a mechanism. It takes it to the, here there is a controller manager, right? The diagram, for the sake of the diagram, I have put it here, but there is a controller manager. So controller manager is there. So it will interact with the controller manager through which it will go to the API server. So controller manager will take it to the API server. API server will process and immediately send that information that one node of this particular one pod with a pod label. There is a label. There is every pod will have a label. Okay. So that label will be defined during the deployment manifest file when we deploy the pods. So it will say that, okay, this pod with this label is down. So we have a replication of 3. Now that particular pod is 1 less. So that information, now immediately that information will again be going to, after getting stored, it will be processed by API server. Now API server will instruct the scheduler. Scheduler has a function. It is a person who can do scheduling very good. So API manager will instruct, see, Mr. Scheduler, there is one pod which is gone bad. Can you do something about it? Scheduler say, why not? I'm expert. I will do that for you. So it will contact, scheduler manager will go and contact, because scheduler manager will have everything, all the details of which pod, which node, everything. It will now contact the controller manager, and the controller manager will take this scheduler activity to the kube proxy. Kube proxy, now this is a reverse path. Kube proxy will take it to the kubelet. Okay. This information from the scheduler will now interact with the kubelet, and the kubelet will, with the help of the scheduler, that function will now replace this with a new pod, with a new pod IP address, because every pod will have an IP address. That's why it can be contacted, because see, everything is over some network. There is a pod network going on between the controller plane and the data plane. There is a pod network. So over the network, all this information passes. So basically, it's a game of network. So that network says that this particular thing has to be replaced, immediately replaced. So it will again make 2 to 3. So this pod, which was with IP address, some IP address, will be replaced by a fresh new, but with the same application. Because you have desired 3, you have got 3. So you desired 3 replicas. Due to some accident, you got 2 replicas working, and then it was replaced with 1 replica which was correct. And if in my sessions, in my Kubernetes sessions in our class, we have lots of examples for lots of labs to show you how these things are replaced. You can monitor it. You can watch it. Okay, the pod will be replaced with a new IP address, with a new pod, with a pod ID, with a new pod ID, with a new pod name, you can say. So any question, how things work inside a Kubernetes cluster? So now you got it replaced from 2 to 3 immediately, but I have taken a lot of time to explain you, but it happens within fraction of seconds, less than fraction of seconds. So efficient. Because it is not the case of one pod. There are thousands and thousands of pods. So if I take too much of time in replacing one pod, then what will happen to the others? Because let's say at any point of time, there are 100 pods which have gone down. So if you take so much of time in just replacing one, what will happen to the other 99 pods? It is not like that. It is instantaneously it happens. That is the efficiency
Hi,
of.
Debasis.
Yes, yes.
Hi, thank you for explaining this one. So, like in one cluster, like what is the maximum number of pods we can fit? Let's say we have one Java app. So for
Yeah, yeah.
Java app, how many pods we can fit? Means
I,
how we get to know that particular Java app, how many pods we should install? How we get to know this one? Yeah.
yeah, that is actually the application architect who will decide how much. See, because these pods are hosted over the node. So what is the node
Mm-hmm.
capacity and how much it can be scalable, whether it's a horizontal scalable or vertical scale. That means vertically you can scale CPUs and memory, but then you can go for horizontal scaling when you add one more node to this. So you replicate or you get all these nodes replicated over, cloned over to the other node. But that is an extreme case of scalability. You generally go for vertical scaling. Those are automatically done. But minimum, you will configure the worker node as per your requirement. And also the thing is, number of nodes in that cluster will depend on your uh, application and the number of microservices that you have. It is not that this application is all over the one node. You can distribute, say, three of this is working over in this node, and another three of it is working on the same Java application is working on the other node. So if something happens over this node, immediately this will take over. Or there is no standard. I mean, there is a round robin logic of how will you rotate between the distribution that is from the load balancer. How will it load balance between the nodes? So this node is too much of uh, traffic. So at
Mm-hmm.
one point of time, it can go out of resources, even if you have horizontally scaled or sorry, vertically scaled, and some there can be some limit. Then automatically this will be sort of something like that kubelet will give a instruction to the scheduler that this is the heavily loaded node. Okay, why don't you shift over to the other node which is quite reasonably not that busy, and those pods are already available over here. So you will distribute. So that is a part of architect to design how many nodes you will configure over, how many pods you will configure of that same application over this, and how many over the other nodes. So if it's a huge application and you need that application to be available 24 by 7, all the 365 days, you need to have an architecture where it can support that particular function. That means it is like a Amazon e-commerce uh, portal where you cannot afford to have any downtime. So if your availability is utmost important, sometimes what is the prerogative? Whether you want, what is the priority? Whether you want the availability or you want the performance? Because between switching between the nodes is a context you switching. Context switching is a resource intensive process. So it can take a bit of latency. Okay. So if your priority is performance, what is your priority? Whether availability or performance. If performance is first priority, then you have to configure your worker nodes similarly, which can which can cater to millions and millions of requests coming over onto the same worker node. Or maybe you have a load balancer installed in between the user and your application, which will load balance the traffic between the distributed nodes. There are so many things that it goes into
Okay.
consideration. Did I answer your question?
So, yes, Debasis, very much thank you.
But
And
yes, yes.
basically, the conclusion is based on the priority. Like example, in the same node, if you have priority to increase the CPU or memory, we can go with or the vertical scaling. If we, in case
Yes.
we want to increase the computation power or what availability, we can go with horizontal scaling with respect to additional of extra node, correct?
Yes.
So we
So
have to
all
see
this
the
configuration.
developers.
Yes.
Developers.
Yes. Yeah. This developer or architect, now you will sit with your Kubernetes manager or Kubernetes guy and your architect and the developer. All three can sit down and decide the configuration. So you can do the configuration over Kubernetes itself while you are installing the Kubernetes
Got it.
cluster. So all these decisions have to be taken before you install the cluster, because you are uh, going to install the cluster in such a way that you configure. So what much of memory, how much memory goes into worker node 2? How much of
Yeah,
memory will go into worker node? So all these things have to be predetermined before you install the cluster.
yeah.
And you
We have to
decide,
discuss. We have to
yes, you have
discuss
to
with the
discuss.
developers
And
also.
if, yeah, everything is configurable through your manifest files while you install your Kubernetes cluster. So it is all Kubernetes that can be taken. Your application do not need to be changed for all these things. You just instruct or configure Kubernetes accordingly.
Thank you, Debasis. Please continue.
And even,
Thank you.
yeah, no problem, no problem. And even after the configuration or after the installation you have done, so that is the reason so many so many companies are now going for EKS or AKS.
Mm.
Because
Yeah,
if I,
because
yeah,
yeah,
tell
yeah,
me.
please. Yeah, yeah, yes, correct. I observed this scenario while when we having the issues with actual Kubernetes, right? So I have
Yeah,
faced these issues. They are talking with alternatives instead of going with native Kubernetes. They're going with
yes,
AKS Azure, AKS services because
yes,
all the things is self managed by AKS Azure. There is
exactly.
no need to manage by our DevOps guys or developers guys. So no need to
Yeah,
manage.
you have
So
to just you have to just while you are installing over the EKS, that is Amazon Elastic Kubernetes Services or Azure Kubernetes Services on Microsoft Azure Cloud. So, and during the installation, you can also configure. That is the beauty. So you configure on the EKS what are the things that you need to do, and thereafter everything will be taken care. After that, according to your configuration, everything will be done automatically inbuilt within the EKS. That is
yeah,
because that being again a SaaS.
yeah, yeah. Because minimum configuration, maximum deployment,
Maximum throughput.
faster
Yeah,
deployment, faster
maximum.
deployments. Yeah,
Yes, exactly,
very
exactly.
nice, very nice, very nice. Thank you.
So that is what I was saying, that I would like to discuss this only after we have discussed the basic things, the flow. You have a kubelet on the worker node. You have a kubelet on the this thing as well, on the master node as well. Because can anybody tell me why? Why do we need you have a kubelet, which is the pod manager? Are there any pods over here? Why should you have a kubelet? There is a kubelet component also when you install your master node. You will see that there is a kubelet also installed over here. Why it is so? See, the kubelet is managing the container runtime. These are all containers. These are pods. So it is the manager. But where is the pods here? Or am I saying that this API server is also a pod? This scheduler is also a pod. This controller manager is also a pod. And this HCD is also a pod? The answer is yes. They are itself pods or containers. That is an application within a container. So it's a component, but it is still an application. So it is a pod. This is a pod. This is a pod. This is a pod. Pod means container. And to manage these pods, you need to have kubelet component, which is also a pod. So a pod is managing another pod. That's fine. That happens because this is also an application. So this is a pod. So therefore, there can be a tricky question from the interview that whether there is a kubelet component on the master node. You will say yes. Because these are all whatever we say, cloud controller manager, replication manager, controller manager, scheduler manager, API server, all these are pods. They also need to be managed. Because who will carry?
Okay,
Yeah.
Debasis, one follow-up question. So,
Yeah.
like, let's example, I have one doubt. Like, if control plane goes down, if all this worker nodes also goes down, or it will be still working
No,
because kubelet is
very good question. All these
okay.
things will keep on working, all working. So basically, there is no need. But when is the need comes? The need will come, say one container down. Okay, you are not getting it replaced. Why? Because your control plane is down. Fine. I still have two. One more controller or one more pod down. Because pods are ephemeral. It can go down. That is the beauty. Don't worry. Because you have desired three, you will always get three if your controller is there. Control plane is there. But right now, as per your question, your control plane has gone down. It is also a server. Please remember, this is also a server having some operating system. Now, this has gone down means this will not be replaced. This will not be replaced. So you are running a risk that your Java application is now, there is a lot of traffic. It cannot handle. So whether it goes down or not, the traffic becomes very slow because it is only getting processed through some cycle, uh, time time cycles of one traffic getting some slice of that time, another then gets so the process becomes very slow, and at one point of time this pod will also go down. So what happens? There is a bad user experience. Your system is down. That is where, for the availability is the most important part. Performance is the most important part. What happens? Your availability has gone down, your performance has gone down, and finally, your application is down. So that's why, till the point, yes, if all the three are working fine, all this are working fine, no issues. And this can go down. And in the meantime, you will rectify, your Kubernetes manager will rectify, admin will rectify something, it will be made up. Once it is up, whichever is down, let's say this one was one down, immediately that will be brought back to the desired state
Okay.
within fraction of.
So in this case, like if we take the same example in EKS or AKS, we don't need to worry about control plane, right? We
No,
have to
no,
only
no,
focus
no.
on worker nodes. Okay,
Yes, exactly.
that is the
You
main
just
advantage
focus
of this. Okay,
this
okay, okay,
case.
got it.
Yeah.
Because we have
So
to focus only on worker nodes, not for control planes. Yeah.
not for the control plane. Control plane is entirely taken over and managed by EKS,
EKS are assured of that. Yes.
because Amazon will ensure that this never goes down. Even if it goes down, it will be brought up within seconds. You will not feel any difference. And therefore, there is a cloud. That's why it is a bit grayish, a light gray, and there is a dash. It is not mandatory, it is optional. So in your thing, you may have a cloud provider API. So in this case, if you have an EKS or an AKS, Azure Kubernetes Service, or Elastic Kubernetes Service, Elastic Kubernetes Service from Amazon, AWS, and AKS is for Azure, Azure portal, which is the cloud from Microsoft. Now they are the strongest competitors. Okay. Then there is one more cloud controller which will interact with the cloud provider API, and the cloud provider API will take you to the EKS. So I can have a native cloud, native Kubernetes master node, which can interact with the EKS uh, or any cloud API provider. In that case, I will have a cloud controller manager. So if some of the functions are going to be managed through AKS or AKS, EKS or AKS, I will have then the fifth component within. I will have to install the fifth the control plane master node. So basically, it is during the EKS installation that you will end up having an extra cloud controller manager within the master component within the master node. Is that part clear?
Yes, there was no doubts for me.
Okay. So keeping this in mind, I will see. I will remove this. We have done 11. We have another, say, mm, another 15 sort of things, 15, 16 slides that we will complete next weekend.